In order to add and subtract rational expressions, we have to go back and review something called finding the least common multiple. It's just we're going to do it with a little bit more complicated expressions than we did the last time. But to start this problem off, I'm going to look at just this part of each of these expressions, because that'll let us review what we had done in a previous unit. So in order to find the least common multiple, the first thing I would do is I would take those expressions and I would write them in prime factorization. So 12, which is 4 times 3, which is 2 times 2 times 3, is 2 squared and a 3. We have an x squared and we have a y. And I don't know why my little dots aren't coming, but there they are. Now let me go over to 18xy cubed. 18 breaks down to 2 and 9, which is 2 times 3 times 3. So it's 2, 3 squared, x, y cubed. The way the least common multiple worked is we took each factor and took the largest exponent of each factor. Now when I say each factor, I mean 2 is a factor, 3 is a factor, x is a factor, and y is a factor. The question is, what's the largest exponent of that factor in either prime factorization? Well, the largest exponent of 2 is squared. The largest exponent of 3 is squared. The largest exponent of x is squared. And the largest exponent of y is cubed. So that's going to be the least common multiple of those monomials that are in front of each of the trinomials. Well, now let's tack on those trinomials. We're going to write them in factored form as well. But when we write trinomials in factored form, those are the ones that we write as the product of two binomials. That means we look for the numbers that multiply to give you the last term, but add to give you the middle term. So in the first one, the two numbers that multiply to give you 1, but add to give you 2 are x plus 1 and x plus 1. Well, that's x plus 1 squared, isn't it? In the second trinomial, x squared plus 5x plus 4, it's going to break down into x plus 4 and x plus 1. So now let's talk about all the purple factors. I have an x plus 1, I have an x plus 4, and I have another x plus 1, so I'm not going to write it again. Well, what's the largest exponent of x plus 1s? Well, we have a square. And the largest exponent of x plus 4 is 1 because there is only one x plus 4. So to find the least common multiple, now we're going to multiply all this together. We're not going to distribute out the binomials, though. So 2 squared times 3 squared times x squared times y cubed is going to be 36x squared y cubed, and then we're going to have an x plus 1 squared and an x plus 4. And that is the least common multiple. Like I said, this is a little bit more complicated than the ones we'd done previously. Previously, we had just dealt with the monomials and finding the least common multiple. So when you get to the got it problems, anything with plus or minus signs between it, look for a greatest common factor to take out, or if it's a trinomial, factor it into the product of two binomials. In order to add fractions now, in order to get our common denominator, because as you recall, in order to add two fractions, you need a common denominator, we're going to find the least common denominator, which means finding the least common multiple of the denominator. So the first thing we're going to do is we're going to make the denominators be in factored form. Most everything is already in factored form with the exception of that trinomial. So in factored form, the two numbers that multiply to give you 2, but when you add them you get -3 are -2 and -1. The reason I put the first denominator in parentheses is because I want to remind you that it is itself a factor. Okay, so the next thing is I need to know what the least common denominator is. The least common denominator is the biggest exponent of all the factors. Well, the first fraction has a factor of x minus 1, as does the second fraction. And the biggest exponent of either of them is 1. The second fraction also has a factor of x minus 2. That means the least common denominator is x minus 1, x minus 2. I want both fractions to have that denominator. Well, the second fraction already has that denominator, but the first fraction is missing an x minus 2. So I'm going to tack on an x minus 2 to both the numerator and denominator. Why do I do that? Well, let's think back to a simplistic case of adding fractions. If I wanted to add 1/2 and 1/3, the least common denominator is going to be 6. So I basically need to multiply the first fraction by 3 over 3, and I need to multiply the second fraction by 2 over 2, and that's how I'm going to get my common denominator so that I can actually add the fractions. I'm really doing the same thing here, even though I'm working with algebraic expressions. All right, so now this is what I have. I have in the numerator x squared minus 2x because I distributed, and I'm going to add to that a 2x and a minus 1 because now both fractions have the same denominator. Remember that the order doesn't matter. They really have the same denominator. So now that I've added the numerators, I'm going to combine like terms. Notice that these are opposites and they cancel. So I'm left with x squared minus 1 on top. Wait a second. X squared minus 1, I recognize that. I feel like I've seen that before. That's our difference of two squares. It factors into x plus 1, x minus 1. Wait a second. If I factor that, don't I have something I can cancel from the numerator and denominator? I do. And I find out the final answer is x plus 1 over x minus 2. That's what I get when I add those two expressions together. Now I also need to go back and think about the restrictions. Because these were my denominators, you can even go back to the very beginning and talk about those factors. It doesn't matter. You end up with the same thing. We know from the very beginning that our domain restrictions are that x cannot equal 1 or 2 because both of those denominators make the original problem undefined, even though the 1 doesn't make the final answer undefined. So when doing the got it problem, make sure that any denominators that can be factored are factored, and then find the biggest exponent of each of the factors. If you have a fraction that needs an extra factor, multiply it, and then add your fractions together. So now that we've done adding, we got to go do subtracting. With subtracting, you need to be a little careful, and I will show you what you need to be careful with, and it's something that you should already know. All right. In order to add or subtract fractions, we need a common denominator. So the first thing I'm going to do is factor the denominators if they can be factored. I want you to notice the first denominator, both share a common factor of x. So if I take out an x, I'm left with x minus 2. So my factors in the first denominator are x and x minus 2. In the second fraction, both of those terms are divisible by 2. So I'm going to factor out a 2, and I'm left with x minus 2. So the least common denominator is the biggest exponent of all the factors. Well, I have an x, I have a 2, and I have an x minus 2. But the biggest exponent in either of these is 1. One of the common mistakes that students make when they do common denominator is they want to make the x minus 2 squared because there are two of them. But we're not multiplying everything in the denominators together. We're multiplying together only factors. So I want you to notice that both denominators already have an x minus 2. So I don't care about the x minus 2 right now. I do notice that the first fraction is missing a 2, and the second fraction is missing an x. And now I want you to notice I have a common denominator. But I have to do some multiplying in the numerator, and this is where we're going to be careful. So I'm going to start by this. I'm going to distribute the numerators. I'm going to get 2x plus 4 in the first numerator. And I'm going to get x squared plus 2x in the second numerator. All right. This minus sign, you're going to have to pull off the plus a negative. But you're going to have to distribute that negative to everything in the second numerator polynomial. If you kind of ignore the denominators for a second, it's the same thing as subtracting those two polynomials. And when we subtract polynomials, you have to distribute the negative to the second polynomial. So now when I combine the numerators, I get 2x plus 4 minus x squared minus 2x, because that's what I get when I distribute. Now I'm going to combine my numerators. So let's see, I'm going to write this in descending order of powers. I have a negative x squared. Those cancel because they're opposites. And I have a plus 4. Oh, I hate when I have something that starts with a negative. And I had told you in a previous section that you can put the negative outside a set of parentheses by changing the signs of everything else. It's the same as dividing both terms by -1. And the reason I want to do that is because now x squared minus 4 is one of my special quadratics. It's the one that factors into x plus 2, x minus 2. And look, those cancel. And I'm left with negative x plus 2 all over 2x, which is the final answer, also the final answer in the book. But you need to look here to write your domain. Your domain is that x cannot equal 0 or 2. Now remember when you do the got it problem that you're going to have to distribute a negative to the second polynomial after you determine what your common denominator is. You determine what you're going to multiply by. Remember, in order to get both denominators to be the same, you have to multiply both the numerator and the denominator by the same thing. Those are the rules for adding and subtracting fractions. And that's the end of part 1 of adding and subtracting rational expressions.